So far we could have seen and learnt the main features of binomial theorem with positive integral index. And now this is the time for us to look towards binomial theorem with rational index. Well, we are now to study the nature of the expansion 1 plus x whole to the power of n when n is a rational number. Of course, we may have to see what are all the conditions in which it can be expanded, its expansion is valid, and what will be the nature. Is it the sum of finite number of terms or an infinite number of terms? These are all the things before us. Beyond that, there has been another question. Why is it necessary to look at 1 plus x whole to the power of n? Why don't you see a plus b whole to the power of n? Of course, even if you get a plus b whole to the power of n, this can again be taken as a power n into 1 plus b by a whole to the power of n. And this looks like 1 plus x whole to the power of n. If you can study the nature of this expression, rather this expansion, the nature of this, full study of this can be done just by multiplying with a power n. That is why we are interested in dealing with 1 plus x whole to the power of n. N is a rational number. And mod x less than 1, the t is minus 1 less than x less than 1. Then 1 plus x whole to the power of n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube plus etc 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 n into n minus 1 into n minus 2 into n minus 3 into n minus of r minus 1 by r factorial into x power r plus so on. That's it. This is the expansion, of course, when n is a rational number. Well, my dear friend, you might have observed one thing. This is, if at all n is a natural number, what is NC1? N. Yes. What is NC2? N into n minus 1 by 2 factorial. What is NC3? N into n minus 1 n minus 2 by 3 factorial. What is NCR? N into n minus 1 n minus 2 etc etc n minus of r minus 1 by r factorial. You see, we are not using the symbol, but of course we are using the same answer. Why are we not able to use the symbol NC2? Because n is not a natural number, n is a rational number. You are not supposed to use that symbol. That's it. Moreover, one of the most important precautions that must be taken to expand this is mod x must be less than 1. Mod x must be less than 1. We shall now study the different aspects, rather different models of problems on this expansion. What are they? Out of them, very first question, or rather first aspect that we have to look at is the validity of expansions. How can they be studied? Yes. 3x plus 2 whole to the power of 3 by 2 is valid if. When can you say that this 3x plus 2 whole power 3 by 2 is valid? If. That is the question. Observe this. This can be taken as 2 into 1 plus 3x by 2 whole to the power of 3 by 2. You ignore this. Observe this expression. This looks like 1 plus x whole to the power of n. N is a rational number, and in the place of x we have 3x by 2. When can you say that this expression is valid? Is valid if and only if mod x less than 1, that is mod 3x by 2 is less than 1. That is if and only if mod x is less than 2 by 3. and that is if and only if minus 2 by 3 is less than x less than 2 by 3. A beautiful question. Let us try to answer one such question on this part. Look at this. 3 minus 4x whole to the power of 5 by 6 is valid. Is valid if and only if, come on, this is 2 by 3, constant term by coefficient of x. That is valid if and only if minus 3 by 4 less than x less than 3 by 4. Like that, you can be in a position to answer or trace the region in which the expansions are valid. Yes. Important expansions. Basing on that formula, when n is a rational number and mod x is less than 1, 1 plus x whole to the power of n is equal to, we have had a formula. According to that, let us try to have some important expansions. 1 plus x whole to the power of n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube and so on. If you put n is equal to minus 1, what happens? 1 plus x whole to the power of minus 1 is equal to 1 minus 1 into x minus 6 plus x square minus 1. Minus 1 is minus 2. Minus 2 into minus 1 is plus 2. 2 by 2 factorial, they'll be cancelled. Like that, if you go on like this, it is an infinite series. Of course, if mod x less than 1. If mod x less than 1. Good. What happens for the expansion 1 minus 6 whole power minus 1? You just replace x here by minus 6. What can we have? 1 plus x square plus x cube plus x power 4 and so on. Well done. Now let us take minus 2 in the place of n. What happens? 1 minus 2 into x minus 2x minus 2 into minus 2 minus 1 is 3. 2 will be cancelled. Plus 3x square minus 4x cube plus 5x power 4 minus etc. 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 What is the fate of 1 minus x whole power minus 2? You just put minus x for x here. Minus of minus x is 1 plus 2x plus 3x square plus 4x cube plus 5x power 4 and so on. 1 plus x whole to the power of minus 3. What is it? Put minus 3 in the place of n in this formula. 1 minus 3x minus 3. Minus 3 minus 1 is minus 4 plus 12 by 2 is 6. Next, minus 3 minus 4 minus 5. Minus 3 minus 4 minus 5 minus 60 by 6 is minus 10 x cube. 1 increased by 2, increased by 3, increased by 4, now increased by 5, again increased by 6 and so on. Exactly in a similar fashion, you can trace the formula for 1 minus x whole power minus 1 also. 1 minus x whole power minus 3, it is 1 plus 3x plus 6x square plus 10x cube. Every term will be plus. Well, my dear, it is very essential, of course, to observe the style of obtaining them. For 1 plus x whole power minus 1 and 1 minus x whole power minus 1, 1 x x square, x cube, x power 4, x power 5, powers of x will only be obtained, of course, with the coefficients as either 1 or minus 1. In 1 plus x whole power minus 1, the coefficients will be alternately plus and minus, whereas in the case of 1 minus x whole power minus 1, all the coefficients are equal to plus 1. Good. You see, you can have the general understanding like this: plus, minus, opposite sign. Then the terms will be alternately plus and minus. Minus, minus, same sign. All the terms will be plus. Plus, minus. So the terms will be alternately plus and minus. Minus, minus, same sign. All the terms will be with positive coefficients. Plus, minus, opposite sign. Hence the terms will be with the alternate plus and minus. What I mean to say is positive and negative coefficients. 1 minus x whole power minus 3, negative, negative, both the signs here. Therefore every term will be with positive coefficients. That's it. These two can be remembered with a type of understanding that every coefficient is either 1 or minus 1. These two can be understood with another type of understanding. The terms will be continuously increasing by 1. 1, 2, 3, 4, 5, 6, etc. What is the coefficient of x power 5? 6. What is the coefficient of x power 10? 11. Of course, plus or minus. What is the coefficient of x power 15? 16. What is the coefficient of x power n? N plus 1, like that. And here, for these two, another special kind of understanding. Coefficient of x, 1 plus 2. For x square, 1 plus 2 plus 3. For x cube, 1 plus 2 plus 3 plus 4. Of course, positive or negative according to the expansion. Coefficient of x power 4, 1 plus 2 plus 3 plus 4 plus 5. Coefficient of x power n, 1 plus 2 plus 3 plus etc. etc. up to n plus 1, like that. This is the beautiful way of keeping an understanding about the coefficients of the expansion. These two will be of one kind, these of the second, these of the third. Have a note of that.